topic, because you want to make sure that you can give the world how to do more with less. You want to make sure you get rice with less water, less fertilizers, less pesticides. A number of challenges in agriculture. First thing is climate change. Carbon dioxide is increasing, temperature is increasing, limitations of waters, well, sometimes with the flooding, too much water locking in Thailand for 5 to 6 months, 3 years ago. But this is well known. And even without climate change, the plants would have to experience the changing environments every day, day in and day out. But again, the climate change will be one of the biggest pressure on humankind in the next 100 years or more. There is a challenge on loss of biodiversity. We are losing things that we don't really yet know what they can be worth for us. There's changes in globalizations, but the biggest change I want to point to you today is a change in demand of biofuels. Only 5 years ago, we were debating, do not put food in biofuels production because it's a big competition. But maybe 10 years from now, we will have to face the problem of not being able to put enough produce into biofuels anymore, because biofuels may not be competitive with the gas that come from cracking techniques in the US and all over the world. Energy may become very cheap, may become very, very cheap. It's impossible to think about this 5 years ago. But this is a really game changer. Cracking techniques have opened up new possibilities for cheap energy. And it is going to be technology transfer throughout the world. Maybe we will have more food than we have. And then what to do with it? The key is, I believe, please keep an eye on, or keep one hand on the value of the products, not just efficiencies. Even food surplus, you will have to increase efficiencies anyway, but you can do more by adding values to the products. And there are other crises. The financial crisis may be coming sooner than we thought. China is looking scary, scarier every week. And there's a cold war on exchange rate. This has been going on for many, many years. And many issues to come with the global warming. Come back to the theme of the conference. Stress. Well, stress is the external factors, but stress is a strange thing. I always compare this to value. To determine value of a person, we cannot do it by ourselves. The value of something is always determined by people around that things, people who wants to buy that things. People of Ajahn Apichat, people like Ajahn Apichat, the value of Ajahn Apichat. Ajahn Apichat cannot set the value by himself. People around him are the ones that set the values for you. And stress is the same thing. We cannot measure stress looking at the temperature. We have to look at in relation to the plants. If we want to talk about the plant stress. So normally we have to look at plant survival, the yield, the growth of primary processes. And we need the high throughput measurement of stress. And I'm very glad that there's a representative from Qubit system to talk about this today. I took this slide from Mark from Australia. Well, biotechnology has been developing very, very quickly. It's unbelievable what has been done in the past 20 years. But phenology, phenotyping, has not been developed as quickly as should be. So phenotyping lags behind so badly. Phenomics is going to be the big thing that we have to work on in the next 10-20 years in order just to catch up with genomics things. And it become a bottleneck in the development, in the research that we have. I believe John O'Toole said this from Rockefeller Foundation, said this long time ago. And he said that the paramount need for high-quality phenotyping screening is noted as perhaps the major impediment to success in conventional or marker-assisted selection breeding. Transgenic rice with experimental promoters and genes of interest will be no less in need of unequivocal phenotypic evaluation for drought tolerance. And I think only a few years after that, we knew that BSF plant science have worked on the crop yield improvement. One of the crop that they work on was rice, and they work on crop design and metanomics. They look at a number of genes, and then they have made a lot of progress using the high throughput phenotyping system. The screening strategies that normally use salt stress, drought stress, nitrogen limitation stress, and this is the way to implement stress experiment. There are a number of high throughput screenings. You will hear from Qubit. I show you Lemnatech system here. But again, there are a number of things that we have to look at: the nutrient toxicities, heat stress, cold stress, water locking stress, and maybe photooxidative stress could be one of the stress that we can use high throughput screening system. I don't know, but oxidative stress is actually a key in all kind of other stresses. The high throughput measurement of stress, there are a number of things that have been done or possibly be done. But some of the difficult things like the root system analysis has even been done. But I still wait for the new development for something like the limitations in photosynthesis, the carboxylation, the electron transport capacity, the triose phosphate utilization limitations. Can it be done in the high throughput phenotyping system? I don't know. Well, people say that chlorophyll fluorescence can be used to estimate these kind of things, but I haven't really seen it yet. But the thing is, I haven't really followed the advancements in science for quite a while. I'd like to show you this another things, the response to temperature. There are a number of things here. But what's normally forgot, at least in Thailand, is importance of acclimation. This data is from rubber. It's photosynthesis in response to temperature for rubber grown at 18 degrees and 28 degrees a big difference. And when we use modeling to predict the response of plants or rubber plants to global climate change, if we don't take into account of acclimation, we will lose. We will make bad predictions. I don't see anything that can help us to do the high throughput phenotyping for leaf water potential or embolisms, which is very important. In fact, in rice, I have seen limited numbers of papers on embolisms, which can be, I believe, can be very, very important. And it's the first time in my life in Erie 10 years ago that I learned that root pressure can be very important things, because it helps makes the bubble dissolve back into the water and reduce embolisms during the nighttime. So rice genetic improvement and productivity. A number of papers have addressed this, and Eric's paper is in the middle here. And he said that rice yield increase were dependent on harvest index up until 1980s, after which the relative importance of biomass accumulation and photosynthesis began to increase. This indicates the transition from sink to source limitation. But I think the keyword in the next decade is really stability. And stability means achieving the yield potentials, no matter what environmental challenges are. And I truly believe that oxidative stress research could help us to increase stability of the production of rice in the near future. Well, I like this quote from Charles Darwin very, very much. I think it has held true for the past 150 plus years. In the long history of humankind, those who learn to collaborate and improvise most effectively have prevailed. We experience a lot of stresses ourselves. We experience a lot of competition. And a lot of people don't realize that competition and stress are probably the most important things in our lives, in humankind, because it causes us to be better, to do more. It causes us to evolve. And it's really good for you. I congratulate you that you have a lot of challenges coming at you, and I know that you are very capable of doing it. So please, you are on the right track. You will try to collaborate, and I'm very happy for Thailand, especially for Kasetsart University, that we would have opportunities to work with the team from UK. And we hope that Dr. Pichat's team and Dr. Eric's team can collaborate to make things better for us and for the next generation. And you will be the change that you wish to see in the world. Thank you very much.
Thank you, Dr. Poonpipop. So he gave us a big picture of plant productivity and different kinds of stress. Anybody would like to add to that, or questions or comment for Dr. Poonpipop? So if that's a no, so after this we will have a coffee break, but before we go there, I have little announcement for participants who haven't posted your posters. please go to the poster session back of this room, and our staff will be assisting you back there. And after this, we will have a coffee break downstairs for about 30 minutes, and please be back to this room by 10:30. And I think Dr. Apichat would like to have a group photo downstairs or up here. Okay, please everybody go downstairs for the group photo. Okay, all right, thank you.